Welcome to MakerFun, powered by Brilliant Labs. I'm Nellie, and I'm so glad you could be here with us today. Today, we're going to learn a little bit about computer programming without even using a computer. We're going to code our own board game, a fisherman's knot, and a treasure map. We'll learn to make a secret cypher wheel to pass coded messages with friends, and we'll learn how binary, all those ones and zeros that computers use, is like a mysterious language. Now Sarah and Lennon from Nova Scotia are going to show us about binary coding.
Everybody, and welcome to another MakerFun activity. I'm Sarah.
And this is Lennon.
And we're going to be looking at binary code today, which is the way that computers represent numbers, letters, and symbols.
Like zeros and ones.
That's right. And for every letter and number, there's how many zeros and ones?
8.
In total. Wow.
They can also create a gigabyte.
That's right. So when we have a series of 8 zeros and ones, that's equal to a byte. And as we get bigger and bigger, it's equal to megabytes,
gigabytes,
and even terabytes. So for today, we're going to make a bracelet or a keychain that's going to need a total of 2 bytes to represent 2 letters, an initial for a first and last name, or whatever you want the 2 initials to be. But it's going to be 2 letters or possibly 2 numbers. But we're going to work with letters today. So that means if we need 8 beads to equal 1 byte, and we need to make 2 bytes, how many beads do we need altogether?
16.
Exactly. For today's activity, we're going to need 2 different color beads. What colors did you pick, Lennon?
I picked purple and blue. Today we're going to be doing the initial for Brilliant Labs, B and L.
Excellent. For today, we've included a link to a chart for the representation or the code of binary and alphabetical numbers. If you don't have ability to print it off at home, that's fine. We're also going to have it up on the screen. We have our alphabet that equals our binary bits. So A starts off with a black square that's equal to 0 and then followed by a white square, which is 1. So today we're going to be using the code that a black bead or a black square is going to represent the 0 and the white squares are going to represent the 1. Now you can certainly choose whatever color beads you want. You just need to make sure that you stick to the 2 colors for each one. So today we've decided to use our
purple and our blue.
Exactly. And we happen to have more purple than we did blue, and we looked ahead to see what the initials for B and L are, and we realized that we need 12 zeros altogether and 5 ones. So we decided that we would make the purple our 0 and the blue our 1s. So let's get started. So our first letter that we're going to spell is going to be B, which Lennon has the pipe cleaner here, and a B starts off with a 0, which is our purple bead. So we're going to go ahead and put 1 purple bead over on it. So the letter B is 1 0, which is our purple bead, and then a number 1, which is our blue bead, and then 2 more zeros, which is 2 purple beads. How many do we have altogether now?
4.
Which is half a byte. So we have to finish the rest of our byte, which is 4 more beads for the letter B. So for B, we have 4 more spaces to fill, and that's going to be 2 more zeros, so 2 more purple beads, and then a 1, which is our blue, and then a purple. And then a blue bead, and then you're going to finish this byte off with a purple. So we have our first byte of 8 characters, 8 combination of 8 zeros and 1s finished for the letter B, and we're going to go down to the letter L. And the letter L starts off with a 0, which is our purple bead. So go ahead and put a purple bead on there. And if you have extra beads around or stuff that you can put on it, you can always separate your letters with those. We're just going to keep going. And then we have a blue bead because that's number 1 after your purple on your first byte. And then 2 purples. And then we have 2 blues in a row. So 2 1s in a row. And then we're going to end it off with, guess what? 2 purples. So 2 zeros, which is going to give us 2 full bytes. So there's definitely a pattern there I'm seeing a lot more zeros there than there are ones, but it depends on what letters you pick. So if your initials are different from B and L, we would love to see what color combinations you have. And you may not have used purple and blue beads, you might have chosen other colors. So we'd love if you could share your binary creation with us. You can either take a picture and do it on social media, or you can take a picture and send it through the mail. We'd love to see what kind of creation you make, and we really hope that you take your binary creation and share it with someone else. Thanks again for joining us today, and always remember, stay brilliant.
Stay brilliant, everybody, and always have a good time.
Here's Karen to show us how to make a secret cipher wheel.
For as long as we have had language, people have had secrets and needed ways to keep those secrets safe. One way people have protected secret messages is through a method known as a cipher. Ciphers have been used around the globe and have origins as old as ancient Roman civilizations. These amazing tools have created a way for people to encrypt and decrypt messages. Ciphers allow a message to be scrambled, and if the key is known, the message can be unscrambled. The key is the way to organize the incorrect symbols with the corresponding correct letters and allow the recipient to unveil the secret message. Today I'm going to make a cipher wheel that has 2 layers. Both will have the alphabet with a few emoji. Only the top layer will rotate. For this project, you will need paper, scissors, a ruler, a pencil, a compass, and a pin or a metal fastener, sometimes called a brad. Let's create our first layer, a big circle. Next, let's create a smaller circle and cut that out. Now we will need to divide our circles up to fit the alphabet. I'll use a ruler for this step and position my circles as precisely as I can each time that I make a line. I keep dividing the triangles until I have enough for all of the alphabet, and a few extra spots for emojis. Since there are 26 letters in the alphabet, and I want a few extra spaces, I'll draw 16 lines. Each line I draw gives me 2 new spaces, and 16 times 2 is 32. So I'll have 6 extra spots for emojis. I made 16 lines, which became 32 spaces. Now we can write our alphabet and assemble the 2 wheels. My friend Gracie will tell you exactly how we can create a code together and decode it.
Thanks, Karen. Today I am joined by my friend Emily.
Hi, everyone.
We were just hanging out together today, and I thought it would be a perfect time to show how to use a cypher wheel. These are very useful when you're trying to talk with someone and you don't want others to be able to listen in on your conversation.
Like when we want to have secret conversations that we don't want anyone to hear.
Just like how Karen showed us when she was making the cypher wheel, we can see that there are 2 wheels with the alphabet on each.
Before we start, we have to decide on a key to use. Today we chose to make M equal A.
This means that we begin by spinning the smaller wheel so that M is lined up with A. Let's say I wanted to ask, "Hi Emily, how are you?" in a coded message. I can see that each of the letters I need to use has a matching letter on the wheel, so I can write down my message using those matching letters. Now that I have a coded message created for Emily, we can see that it looks just like mixed up words to anyone who doesn't know the key.
Okay, so if I use the key that we chose, which was M equals A, then I can decode the message that she wrote to me.
The nice thing about a cipher wheel like this is that we can use it over and over.
And if we think that someone knows the key that we are using, we just have to decide on a new one.
When we use cipher wheels like this, it makes us think about coding, such as conditionals. This is when something happens only if something else takes place. If this, then that, or if letter M, then letter A.
It also makes us think about cybersecurity. There is always important information that is shared online that needs to be kept secret. To help keep this information safe and secure, programmers use ciphers like encryption tools so that people can't steal the information.
Thanks for joining us, everyone, and don't forget to stay brilliant!
And here's Jacob, a new special guest.
Oh, hello there. I stopped by today because I heard that you were trying to learn how to code without using any computers at all. Is that even possible? Well, of course it is. For instance, think of all the activities that you do in the span of a day that follow a set of instructions. This is exactly what a computer does. It follows a set of specific instructions called code. Once you start thinking about the activities that you do, you're going to see many similarities between you, the coder, and the type of code that a computer follows. For instance, think about when you're baking your favorite recipe for cookies, building a tower out of blocks, or even trying to remember the pattern to your favorite beat. Ta-ta-ti-ti-ta. All of this is very similar to the set of instructions that a computer follows. Another example, my friend Paul teaches physical education here in New Brunswick. Just the other day, he was trying to teach me how to tie a fisherman's knot. This is something to which I have zero experience in, and so I needed a set of very specific instructions to know how to achieve the goal of this activity. So Paul, the coder, created a type of code for me to follow. Listen to this.
To achieve the double fisherman's knot, I'm going to come around. In this case, it would be the yellow rope being the standing part. I'm going to come over and around a second time. Then I'm going to pass the working end through the two blue cordage loops that I've created. Pull that fairly snug by pulling on both of the round loops. Then I'm with the other portion, the yellow segment of cordage. I'm going to come around once and a second time back towards the original double fisherman's portion on that end, and then proceed through my two loops with the working end. Pull that fairly snug, and that gives me two nested together double overhands, which yields what appears to be a continuous strand. It's very strong.
And now Lauren's going to code a board game with us.
Hi everyone, my name is Lauren, and today we're going to be making a coding board game. To make this, you'll need paper and something to write with, and to play, you'll need a die, and something to show the space of all of the players. An easy option for this is coins, buttons, and small toys. This board game is going to be based in conditional or if-then statements. We're going to start off by outlining the game board and decorating it. You can make this part as simple or as colorful as you like. A conditional in coding checks if something is true, and then will act differently if it's true or false. That is why we call them if-then statements. The if step checks if something is true, and if it is, your then step will happen. For example, if your hair is too long, then get a haircut. In this case, your if step checks if your hair is too long. If the answer is yes, your then step is getting a haircut. But if your hair isn't too long, the if step would be false and nothing would happen. Conditional statements are helpful in coding because they allow you to create a program that does more than one thing and will change depending on the situation. That shows up in this game when you either stay on the spot you landed, or move forwards or backwards after that. Once you've finished decorating, we're going to first label the start and end of the board game, and then we'll add in the if-then statements. For this game, they're going to be based on the numbers on a die. The if step will check something about the number that was rolled, and the then step will tell how many spaces to move forwards or backwards. You can try coming up with different if-then statements, but some of mine are: if you rolled a 2, then go forward 2 spaces. If you rolled an odd number, then go back 3 spaces. If you rolled a number smaller than 4, then go forward 2 spaces. If you can skip count by your number 4 times, then go forward 4 spaces. If-then statements can also check more than one thing in the if step. One of mine is: if you rolled a 3 or a 6, then go forward 2 spaces. In this case, the then step will happen if the player rolled a 3, but it will also happen if the player rolled a 6. You can try coming up with conditionals based on what you're learning in math. While playing, you will land on a space, and if there's a conditional written there, you will check to see if the if step is true. If it is, you will follow the then step. For example, go back 3 spaces. If your if step is false, you will stay on the space where you landed, and your turn will be over. This version of the board game uses conditionals based on using 1 die, but you can also expand it to make a bigger game and use 2 or more dice, so your if-then statements can involve numbers bigger than 6. If you don't have dice at home, or want to play with different numbers, you can search for a random number generator online, or write numbers on small pieces of paper and pick them randomly each turn. Once that's done, you have finished your board game. You can play with 2 or more people. Here's how to play. Have all players take their game pieces and start them on the start block of the board game. Then, take the die and roll to start off your turn. Here I rolled a 2, so I'm going to move 2 spaces and check what's written in that space. It says, if you roll a 2, go forward 2 spaces. Since that's true, I'm going to move forward 2 spaces and finish off my turn. Now, hand the die to the next player to keep playing. The game is over when somebody has reached the end space on the board game, and they win. Have fun playing!
Now let's join Kate and Sophie as they code their very own treasure map. That's all the time we have today. Thank you so much for joining us. Reach out and show us what you've made. You can find us on social media. You can even send us snail mail. Just find the website brilliantlabs.ca for all the information you need. Thanks so much to these people for helping us out today. And thanks to our special guests for showing us all this cool stuff. But especially thanks to you for joining us. We wouldn't be here without you. Stay brilliant. We'll see you next time.